M1 lesson 16. For the most part, as a follow-up lesson to lesson 15, solving and graphing inequalities. Again, we'll be looking at situations where they're joined by the word and or. So the outcomes remain the same as lesson 15, to solve two inequalities joined by and or, and to create graphs of the solution set on the number line and describe the solution set of two equations or inequalities. So what we're going to do is we're going to look at a few of the exercises that the students were able to practice in class and talk about how they are related to lesson 15. So here we are in exercise 2, page 92 of the student handbook, where they want us to consider the compound inequality -5 is less than x, but x is less than 4. And so in part A, that's really all they want them to be able to convey and message in that idea is the fact that when we look at it, rewrite the inequality as a compound statement of inequality. We want them to be able to say that x is greater than -5 and x is less than 4 as two individual statements. So then in part B, the students may write something along this idea, is that x is in between -5 and 4. So when we come down here, we find -5, which is right here. It'll be an open circle, and then between 4, so we have an open circle here, and then the student just needs to shade in between the two. In another practice example, exercise 3, we ask students to consider the compound inequality -5 is less than 2x plus 1, and 2x plus 1 is less than 4. So when we rewrite the inequality as a compound statement, we're writing two things. We're saying that 2x plus 1 is greater than -5, and 2x plus 1 is less than 4. So in part B, they want us to solve the inequality for x in each one. So if we took a look at this piece here, the 2x plus 1 is greater than -5, we'll start by subtracting 1 on both sides. So 2x is greater than -6, divide both sides by 2, and we'll note that x will be greater than -3. Same thing here, if we took the 2x plus the 1 is less than the 4, if we subtract 1 on both sides, we get 2x is less than 3, and so we divide by 2, and x will be less than 3 over 2, or 1.5. So they want us to write a sentence describing the values of x, so we would state in the same general fashion that x is between -3 and 1.5. So when I go to graph that, again, we look at this, a greater than sign will indicate that we will have an open circle. At 1.5, it'll be in between 1 and 2. We'll have another open circle. And we'll shade everything in between. So again, most of these have been done in a solve, pair, share. So the students are working together with a partner in class to come up with these answers, and the teacher is generally moving around, helping students as need be, and answering individual questions. So if we looked at exercise number 4, you notice the inclusion here of the word or. So x is less than -3, or x is greater than -1. And so what must be true in order for the compound inequality to be true? Well, at least one of the parts or conditions must be true, as opposed to the word and, that both must be true. So in part B, we want to write a sentence to describe we would say that x can be any number less than -3, and here's the key word, or any number greater than -1. So when we go on and we graph this, if x has to be less than -3, so we'll shade in this direction here, or x has to be greater than -1, and that's shaded in that direction there. So we'll look at one more example. We'll look at exercise 5 on page 93 as well. And so looking at this perspective, it says x plus 4 is less than 6, or x minus 1 is greater than 3. So it wants to solve each inequality for x, and then write the solution to the compound inequality. So if we look at the x plus the 4 is less than 6, we'll subtract 4 on both sides, and so x will be less than 2, as opposed to x minus 1 is greater than 3, so we'll add 1, so x will be greater than 4. And so if we want to write the full answer, we would say something along this like idea: x is less than 2, or x is greater than 4. If we wanted to write a statement, as in part B, we would say that x can be any number that is less than 2, or greater than 4. And so if we wanted to illustrate this on a graph, we would take these values, are 2, which is here, open circle, we'll shade here, and then greater than 4, we'll shade that way.